just dive right into the topic of completing the square by explaining what's a perfect square. Basically, when a quadratic equation can be factorized down to two brackets which looks exactly the same, it is a perfect square. So what you're seeing here is two quadratic equations. As you can see, the first equation can be factorized down to two identical brackets, that is x minus 1 bracket square, which makes it a perfect square. The second equation is factorized down to two different components, x and x plus 2 bracket, meaning that it is not a perfect square. Here's what we're going to do. If a quadratic equation is a perfect square with the coefficient of x squared as 1, we add a number called m squared at the back of the equation as following. Therefore, when we encounter a quadratic equation like x squared plus 2mx, we simply add a m squared to it, with this process usually known as completing the square. Let's look at an example. By adding the square of 10 over 2, that is the square of 5, we will be able to create a quadratic equation which can be made into a perfect square, following the exact quadratic formulae we are asked to recite. In this case, it would be the square of x plus 5. So here we have an equation called x squared plus bx, and by adding m squared, that is the square of b over 2 in this case, we can obtain a quadratic equation which is a perfect square, x squared plus bx plus the square of b over 2. We can then translate it as the square of x minus b over 2. But since we add an additional b over 2 bracket square, we're going to have to minus the exact same amount so the equation makes sense. And so we minus that part and we put it at the very back of the equation. So here's the conclusion. In order to complete x squared plus or minus kx, simply add the square of k over 2, put it in the equation format, and take away the additional part by subtraction. So here are two fundamental formula conversions to consolidate what you learned. And here are some examples for your reference.